Hey guys, welcome back to AlgoYogi. We are now doing array and hashing series, and our next problem in the list is path crossing. So let's go to LeetCode. There you go. Given a string path where path ith value is either n, s, e, or w, each representing moving one unit north, south, east, or west respectively. You start at the origin, which is 0, 0 on the 2D plane, and walk on the path specified by the character in the path if you go from left to right. Now return true if the path crosses itself at any point. That is, if at any time you are on a location that you have already visited, then you're going to return true, otherwise you return false. Alright, so it's a simple problem, really easy to understand. That is why it's marked easy. But let's because we are doing the whole series, so let's just do it. So we are given this string which is going to contain letters from N, E, S, and W, where this means north. So north means going up, east means going right, south means going down, and W means going right. Now on our 2D plane, we are going to start at basically 0, 0. So X is 0 and Y is 0, right? Now because our first string is N, then we're going to go one unit up, all right? So our X becomes, so we're going to basically increment our X. So if, let's say, I think it would be better if I just like declare my X and Y variable right here. And then there is another thing that I'm going to do. Let's just solve it. We are understanding the problem, but let's just solve it also. What I'll do is I'll have a set called locations. This is a set. What is this going to contain? All the X and Y pairs that I have already visited. So far I have visited 0 and 0, 0 and 0, I have visited. All right. Then I am going one step up because of this key N, this character N. So I'm going north. I've also represented it right here. Now, so X and Y were 0, 0. Now what they become? They become X remains 0. And in Y position, you're going one up. So you add 1 to 0. So it becomes 0 and 1. So now we'll add this to our locations because we have visited that. Then it's E. E goes one step to right. So that is why we're going to increment our x-axis. So now X becomes 1 and then Y also becomes 1. So you can see. All right. Then I will also add 1, 1 to my set. Locations, it's a set. So I'm already here now, but then I have S. S means we come down. As you can see right here, you come down. So you'll come down this time because you're coming down on your 2D plane. So it's Y that will decrement. So it's going to become 1 and 0. Okay, now I will add this to my set. Well, I have finished my entire path and I never came across any value that I already visited. So here, while visiting all these characters and moving and then also changing my X and Y values and then adding them to locations, I could keep a check right before I add it to my locations. If any of these value in my location before I add them, then I return true. Right, I return true. Then I can do it in just one pass. And also check if I have visited that position. So let's say right here, I'm changing the first example. It was basically going to S was bringing me to 1 and 0, right? 1 and 0. So let me add one more value, which is W. So that will complete this one full circle. So if I'm adding W here, which means I will travel from here to origin again back. So what I'll do is I will decrement my x-axis. So this X will become 0 and Y will become 0. And this new X and Y pair, this x-axis and y-axis value, I will check if it exists in my locations. Yes, it does. It's right here. So that is why if it does exist, then you will return true. So this condition fulfills and you will return true. Otherwise, if nothing happens in the end, you can just return false. All right, so that will be the entire solution. Here the time complexity of this solution is going to be big of n. That's because we are only doing one iteration from left to right over the entire string, and where n is the length of our path. Space complexity, well, we are using this location set, which is going to be of big of n time complexity as well. So can we do better? Well, in terms of space complexity, time complexity is great, but I guess since we have to keep a track, like if we have already seen that position, then I think we do need to have a space. But if you have a better solution, please chat in the comment section. If you chat, like, then I'll get to know there is a better solution, and I will come back and implement that, learn more. All right, so let's change our view and code up our solution. All right, looks good now. So we'll have a location set, locations, that is going to be a set. But just remember, this set in the beginning, I will add 0, 0, because that's the beginning, right? It will always be there. We are standing there, so we have visited with 0, 0. So I will add 0 and 0. Now my x and y are also 0 and 0. And you know what? Yeah, well, this is okay. What I was saying is, I could declare these here, and it would be better if I said that I'm already starting at this position, so I can just say x and y in my location set. Then I will start, I'll call it D, its direction in my path. So there are 4 directions, right? So if okay, I'm sorry, if D is equals to n, that means I'm going up, which means these x and y, I just want to change my x, so I will just, what I'll do is x will be, no, because I'm going up, so I'm changing y, so y will become y plus 1, x will be 0 itself. Now if it will be one of these positions, right? S, that means I'm decrementing my y, LF, D is equals to east, then I'm incrementing my x this time. Else, it can only contain 4, so I could just simply say I will just decrement my x. Okay, well, now before I add it to my location set, I have to check if this updated x and y, if this is in my locations, that means I'm revisiting a point where I have already been. So that is why I will return true, because the path crosses itself. Otherwise, I will return false in the end. But one more thing, I have to add this location to my locations set. Okay, so locations dot add. What you're adding? You're adding your x and y. You're adding it as a pair or tuple, you can say. So that's the entire code. I hope you can see it. Let's zoom out and run it on our example cases. Great, it does pass. Okay, so I'm gonna submit it. Great, it's actually a pretty good solution. So now let's write the time complexity. So it's going to be big of n, and space complexity is going to be big of n as well, because of the set that I am using right here. All right, then this is done. Let's go to AlgoYogi, mark this problem solved. See you guys later in the next problem. Until then, bye bye.